For people who can't visit different locations, the technology, virtual reality, gives people access to the coral reefs from different sites. In the Hunter Island Challenge, I've tried to bring that perspective into one research project to really understand how the communities change from location to location.
Coral reefs are vital ecosystems home to 25% of marine biodiversity. They fuel fishing and tourism industries, provide resources for medicines, and protect shorelines and people living on the coast. But coral reefs are in danger, facing threats like overfishing and pollution. Due to climate change, the ocean is warming and causing corals to bleach and die off. In response, scientists at Scripps Institution of Oceanography created the 100 Island Challenge to study how coral reefs change over time to effectively inform their conservation and management. They're studying 100 islands and creating 3D models of each reef, bringing coral reefs into the home of anyone with a computer.
You need to visit all these reefs across kind of the entire globe, looking at places like the Caribbean, looking at places like Hawaii, some other remote places, kind of in the middle of nowhere, and you see these amazing reefs.
When we arrive to a site that's been randomly generated via our maps, we get ready to dive, we roll over off the side of the boat, and we search for an area that's relatively flat, that has a representative collection of corals for that area. Once we've established the site, we start staking some stainless steel threaded bars into the reef, so we have some permanent stakes so we can find the site 2 years later. We use some Aquaman or epoxy to make sure those don't move too much. And then from there we establish a 10 by 10 meter plot with a 2-diver team. And while one diver is setting up the plot and taking measurements, the other diver starts to fly the mosaic rig over the plot. So that mosaic diver is swimming about 1.5 meters from the bottom at a slow enough pace that you're collecting about 3,000, 2,000 photos for the entire 100 meter square plot. So that's about 1 photo per second.
We collect all the images in the field. We'll then bring them back to the lab, and we use pretty high-powered processing computers to then take those raw images, essentially put them together to create one large 3D model. Right now what we use is a program called Agisoft PhotoScan, and it uses structure for motion technology to essentially find points within each of those images and features, match them, do this global matching, and then you create a 3D reconstruction of those models. So what we use is actually a dense point cloud, anywhere from around 500 million to 2 billion points, that we then visualize with custom software, and then we can go through, use them, do all these annotations so that we can actually extract data from these models. In addition, we can also create videos, so you get a nice visualization of what that reef looked like. Essentially taking that reef, imaging it in the field, bringing it back to the lab so that you can then view it and make videos, extract data. The type of data that we're looking for are things like size frequency distribution. So how big are all of the corals in your plot? How many species do you have there? So you can go through and identify them because you have all these high resolution images.
Part of the 100 Island Challenge is revisiting reefs from year to year and seeing what's changing. I decided to focus my project on creating time series videos for an island in the middle of the Pacific Ocean called Palmyra. And there was actually a bleaching event that hit there in 2015. So there were really warm ocean waters, and that caused corals to die off. And so I was able to follow different corals and see how they made their recovery. And it was really interesting. There were actually a lot of corals that parts of them would break off, but they were able to come back and start regrowing the next year in 2016. So I was excited to be able to share the story of resilience, and that reefs, if there isn't overfishing and they're not being polluted, and if we can all lower our emissions, that they can come back and recover.
But it's really cool to go to these places kind of in the past year after the bleaching event and see these places that are still doing well and still nice and healthy. And I would say my favorite part of this project is also kind of more along the lines of the technology. We get to work with some really cool, really smart people that are doing these amazing things with 3D imagery, and that allows us to use these in really cool ways and bring these back to the people. A lot of the times you go to these local or you go to places and you work with local partners, and a lot of them actually never really see their reefs or never get the chance to jump in the water. And now you can take these models, kind of visualize them on a computer screen so that anyone can see them. Anyone, pretty much anywhere. You don't have to be a swimmer, you don't have to be a scuba diver or a snorkeler. You pretty much just have to have a computer screen or even a phone to look at these videos and see these amazing reefs.
Part of the 100 Island Challenge that I think is most interesting is that we take a holistic approach to the science. So we're not just looking at the coral, we're not just looking at the fish, we're not just looking at the productivity or oceanography. We're trying to incorporate all the things that will drive a reef to be healthy or unhealthy. And on top of that, I'm particularly interested in how we can incorporate the human side of things. So trying to integrate how humans are impacting the reefs that we look at and how we can continue to use the reef for the people without using